Hello students, welcome to another episode from our electronics essay series. Students, so far we have done 2024 electronics question, 23 electronics question and 22 as well. So today we are doing 2021 electronics essay question. Students, if you haven't done this question before, I'm inviting you to try this question first. Because if you haven't walked through this question before, then you will not face the difficulties. You will not understand the difficulties you might face. So before going through this video, you have to try that question first. Right, students, remember this is one of the easiest question so far. It's really easy. So students who did this question are really lucky back at that time, right. Anyway, there might be certain theories we have to understand still, so let's walk through it. I'm inviting you students, just stay there and you will learn lot from this question for sure. Let's quickly go through the question, part B actually. So electronics essay question 2021. Students, in the first part actually, they are asking us to draw IV characteristic curve for the diode and write down the diode. And of course then we have a diode circuit and we have to find the output values here. Here they have given us a truth table, so we have to fill the values there, and after that they are asking the corresponding truth table for this table we are getting, and we of course we have to find a resistance, and that's the end of part A and B. That's very easy. And part C actually simple logic circuits. They are giving us a scenario, so we have to recognize the scenario, we have to draw the truth table, and we have to write down the expressions, and then we have the simple logic circuits. Right, students, let's get into the question now. Right, now let's get into the question. In the first part, we have the gates diodes part actually. So name the diode which is represented by figure 1. Right, students, in many years actually they have asked us the other way around as well to draw the IV characteristic curve for a junction diode or silicon diode or germanium diode and for ideal diode as well. So here actually they are asking us to draw, asking us to recognize this one. So this is 0.7 followed by 0.7 is for a silicon transistor, that you have to know, of course. 0.3 for germanium diodes. If it's an ideal, it has to be something like this. Alright, part B. Let's read on. Figure 2 and 3 here show silicon diodes and two regions with resistance, two resistors with resistance, R1 and R2. A and B inputs can be 0 and 5 volt, right? 5 volt and 0, right? For all the calculations, use the characteristic curve given in the figure 1, right? This one. For different combinations of input voltage given below, determine the output of VF here and complete the following table for the circuits given in figure 2 respectively. For the purpose, alright, copy it, right. Actually we need to copy this diagram and do it right. So first I'm doing it actually for the figure 1. So let's try it now. Okay, let's put the values. So initially A and B 0 and 0. Here we have 5 volt. So what basically happens is current will flow from this point to this point and from this point to this point as well. So and these two diodes are parallel. So parallel means they share the same potential. That of course we need to know. And forward bias potential is 0.7. So the potential here, it has to be 0.7 because here it's 0. So the difference has to be 0.7. So the point potential at this point, it has to be 0.7 volt. So F output will be equal to 0.7 volt. So I'm going to put it here as 0.7 volt. And let's move into the second scenario now. Now it's 0 and 5. 0 and 5 volt. Actually 5 and 5 between, there's no potential difference, so there will be no current. And but still at the very same manner we did previous one, here we will be having a current towards A actually. So again potential difference is 0.7 here. So F output will read 0.7 volt. In the second scenario, when this is 5 and this is 0, the same thing will happen, student. So this also will read 0.7. Now what will happen when this is 5 and 5? Alright, that means there will be no potential difference, so there will be no current flow, right? No current flow. If there's no current flow, remember students, the potential here is 5 and here also it's 5. No potential difference across this R1 resistor, so no current flow. That's mean no potential difference. So if here it's 5 and here also 5, so F output will be 5 volt. Right, students, we have covered the figure 1. Right, students, now we are moving to the figure. Now students, we are at the figure 3 now. Right, let's write the values. Just like the previous question, here we have 0 volt and 0 volt, and here also we have 0 potential. That means we have no potential difference across these terminals, so there will be no current flow, right? So that means the potential at this point, potential across R2, no potential difference across R2, so no current flow. So the potential here at F, it has to be 0, so I'm going to write it here 0, right? Now it will change here, because now here it will be 0 here, and but here it will be 5, so there will be a current towards here, right? Then so potential difference across this this diode, silicon diode, it will be 0.7 volt. So 5 minus 0.7, it will be 0.7 potential difference across this, so it will be 4.3 volt. So across R2 there will be 4.3 volts, so point potential at F it's 4.3. In the second scenario, again third one, F50, same thing will happen. The potential difference across will be 0.7, 5 minus 0.7, it's 4.3 here again, 4.3. Now in this last one, 5 and 5, both 5. Again, remember students, these two will be parallel. These two diodes are parallel, so same potential will be shared. So 0.7 will be shared, as in it's common actually, 0.7 volt will be common. So the point potential again it will be 4.3. Right, moving into the next part of the question. When considering the output F only, if 5 volt, yes, they are asking us to take it as binary 1, and in the next part of the question, when considering the output F only, 5 volt close to 5, representing binary 1 and 0 as, right, okay. And what we have to do is we have to name the respective gates corresponding to the circuit shown figure 2 and figure 3 and write down that truth table. Right, let's get in. Right, now for this we need to write down the truth table. So initially we are given the not that 0.7 that is closer to 0, we have to take it as 0. So 0, 0, and that is which is closer to 5, we have to take it as 0, 0, 0, 3 zeros and 1. Basically student, this is the AND gate, and I hope you have the clear understanding about AND gates. A and B, if this is C, C is equal to A dot B, these things you should know. And let's draw the truth table. Actually they are asking us to draw the truth table for it, so let's draw it. If it's A and if it's B and for C, right, so what are the possible values? 0, 0, 0, 1 and 1, 0, 1, 1. So for AND gate it's actually here there will be 0, 0, 0 and 1. So this is the truth table for AND gate. Let's move into the next one. Right students, this is the second one, figure 3 actually. So in the figure 3, 0 of course we can take it as 0, 4.3 which is closer to 5, let's take it as 1, 1, 1. So obviously if you have studied students, you know this is the OR gate, right? OR gate. So if this is A, if this is B and C, C is equal to A plus B, So let's draw the truth, right? Drawing the truth table for here it's A, B, and C is the output, and 0 0 0 1 1 0 and 1 1 0 0, it will be 0 1 1 1. So this is the truth table for O gates, students, right? Moving into the next part. Students, this is the 2015 electronics essay question. See the similarity. The question very similar to the previous question, very similar, as in if you have practiced these questions, students, you get the experience of doing questions. And so that's the thing, students. Actually, I have to recommend you to doing questions. Actually, if you are planning to do electronics essay questions, at least you have to cover actually 15 past paper questions. So if you have covered up 15 past paper questions, I'm not saying 2015 questions, 15 amount, right? 15 past paper questions at least, if you have covered them up and if you have revised it properly, it's really easy to do the question for sure. And the third part, calculate the suitable value of R1 and R2 which limits 0.5 milliampere of total current flowing through both diodes in each circuit. Right. In the last part of B, actually we need to find, now they are telling the current through the resistor will be limited to 0.5 milliamperes through both diodes, right? So the total current will be 0.5 milliamperes. So the maximum potential difference across R1 will be, here if it's 0.7 volt, will be 4.3, right? Here it's 5, it's 0.7. So potential, let's apply V equals IR. So potential difference will be 4.3. I is 0.5 milliamperes into 10 to the power minus 3 R. So R is equal to 4.3 divided by 0.5 into 10 to the power minus 3. So I'm going to multiply it by 2 here, by 2 here. This is the way I simplified. So 2 into 0.5, that will be 1. So you don't have to simplify here. So 1 into 10 to the power minus 3 up. So upper it will be 2 into 4.3, it's 8.6. 10 to the power minus 3 goes off. So into 10 to the power 3 equals R. So basically the answer will be, yes, 8.6 kilo ohms is the answer, right? For the second part, of course, same scenario. Here it's 0. The maximum potential here it will be 4.3. Again they are telling it's 0.5 milliampere. Applying the very same calculations, we'll be getting it's 8.6 kilo ohms for R2 as well. Moving into question C. Friends, we are in the third part, as in the last part, the most difficult part, right? This question, students, really easy. As I mentioned earlier, it's really easy question. People who did this question are really lucky. Anyway, but even if the question is really easy, remember, students, if you like move fast into the question, there are cases where you can go wrong. All right, I hope you have read the question now. So now the alarm should ring when f equals 1, that of course you know, and these are the conditions. Now we know the office window open, t equals 1, office close, office hours t0, and after office hours t equals 1, and door close d0, door open 1, and window close 0, window open 1. After office hours, right? After office hours is this, right? Now the student wants to design after office hours if a door or window or in both open, actually the alarm should ring. That's logical, that's how it should work, right? So in the first question they're asking us to write down the truth table by using this. So let's draw a truth table. These are the variables we have, right? So first one, the office T, right? And then again we have D for door and W, F final one. I'll take it this the alarm, right? All right. See, now we have three inputs. We have three inputs. So in that case, let's draw the truth table. I have given you the instructions. When we have three variables, three inputs, actually that's 2 to the power 3. So we get 8 combinations, students. I have done a video on this. You must have watched it from Logic Gates, SR Flip-Flop and Logic Gates video. If you haven't watched it, it's always better to go and watch it, right? Not now. Let's get into the question. So 8 combinations we have. So how do you write it? 0, 0, 0, 0, 1, 1, 1, 1. 0, 0, 1, 1, 0, 0, 1, 1. 0, 1, 0, 1, 0, 1, 0, 1, right? So let's write down the logic expression, not the logic expression, truth table, right? Now, if the office is open and we don't have to worry about the alarm, right? So once the office is closed, only this part we have to consider, right? Okay. And here office closed after, but still both door and window are closed, so we don't need the alarm, right? And then again, after office close, window is open, right? So we need the alarm. 1. Again, door open, office hours, we need the alarm, right? So this is the truth table they are asking from us. 0, 0, 0, 0. So easy truth table. So this question is really easy, right? Now moving into the second part, obtaining the corresponding logic expression for F, right? So we have done this before, students. I'm telling you again, this is the method we do it. I'm using 3 input AND gate method here. So what I'm going to do is I'm going to write it using 3 input AND gate method, where we have 3 inputs. So A dot, B dot, C is F, something like this. So 1 into 0 into 1, it has to be 1, but once you multiply 1 into 0, that's 0, right? Right. Then how you make it 1? So if here we have bar value, say now if you have 1 value here, so 1 into 1 into 1, that's 1. So basically what I'm going to do like that. So if here I'm going to make it bar. See, T dot D bar dot W. It's 1. In the very same way, I'm going to use for the others. 1, 1, fine. 0, it's not fine. So T dot D dot W bar. And the final one, or is T dot D dot W. Right. The final one we have to, altogether we need to add. So final F is equal to T dot D bar dot W bracket plus T dot D dot W bar plus, right, T dot D dot W. That's our answer, the logic expression they are looking for. Now we have to simplify the logic expression we got. So this is the logic expression we got, and we have to use these conditions. So we have to use these, right? So W plus W bar equals 1, okay, W plus W bar equals 1, and D bar dot, okay, plus D equals DW. Right, to simplify this Boolean expression, W plus W bar I can find from DDW. It's the, let's take these two. Alright, let's take these two, right? So it's like this. TD is common. So T dot D I'm going to take out, and inside I'm going to get W bar plus W, right? So W bar plus W, that's 1. So I'm going to simplify. I can simplify T dot D. That's 1, right? Easy as that. The next part, T, I'll keep it here. So T dot D bar dot W. So here we have T dot D bar dot W. So what's common? T is common, right? So I'm going to take out common. T bar W plus D, that's equal to D plus D, right? D plus W. So T dot D plus W, simply this is the expression actually they are looking for, right? The next part actually they are asking from us, we need to draw a simple logic expression to get this. A simple logic expression, right? Students, if you have practiced these type of questions, it's really easy. I'm repeat telling this actually. So T dot D plus W, we get it from an OR gate. So basically you're going to draw an OR gate that will connect D and W. T comes separately, okay, T here, and this should be multiplied. So we connect by using an AND gate. Easy as that. The question we have done. See students, this question is actually really easy. The only thing that is kind of new here is this the simplification of Boolean expression. So if students, some students actually they haven't practiced this that much because it's not that common in our syllabus in questions and all that. So we need, students, so here we need to remember that we have to practice these things, right? So they can ask any question from any aspect from one particular lesson, so you should be good at it. So that's what actually we can learn from this lesson. Even the question is really easy, but there are some parts that are challenging, but still you can manage to get, let's say the full marks is 15, at least you can get 12, 13 out of this question, right? Right, we have done the question. If you could do it, that's great.